later stage. Okay, so just a reminder, a little bit of admin. We haven't finished marking the semester tests yet. Unfortunately, we're getting there. It's unfortunately this week has been going a bit slow because of all the other work that we're also doing. So please bear with us. We will definitely get to that. Tomorrow, remember, is a Wednesday day. Well, sorry, no, it's not a Wednesday. Sorry, tomorrow, which is a Thursday, follows a Monday class roster. So please make sure that we will have a lecture tomorrow evening, this time, I believe. Just make sure, yeah. So please remember to join us then. And they will, because there's no scheduled tutorials normally on a Monday, obviously then that the tutorial that normally would have been on a Thursday obviously falls away. But you can always watch the tutorial that was recorded on Tuesday and actually get the necessary information for you to be able to complete the upcoming prac. I think that is all that I wanted to say regarding that. Yesterday, we basically just went quickly over the principles of libraries and namespaces again, and it was very much a hands-on type of lecture. I'm going to very much try and do the same this evening because we're going to start with this thing called pointers and dynamic arrays and these kind of things. And I'm going to go through let's call it an explanation, some of the teaching tools that I have, and only then will I go back and refer to the lecture notes. But you have the lecture notes already available on Eve, so please go ahead and actually work through that. You can even see as you work through it and see what I'm talking about during the demonstration components of the lecture, whether what I'm saying actually makes sense. Okay, so let's start without further ado with our pointers and dynamic arrays. So I'm going to share my screen and I'm going to open Excel so that it's one of my favorite teaching tools when we work with pointers and so on. So let me just see as soon as it's available that you can see it. All right, perfect. Okay, so you guys have learned that we have different types of data types in our computers. I mean, I can go and I can have something in C++ and which can do something like this. Let's make it character ch. Let's just call it character, and that is how I declare a variable. Now, as soon as you declare a variable, what happens is the computer goes into a special piece of the memory and it sets aside a portion of the memory so that it can store the value that we're going to put in this variable, but inside that memory location. Now, memory locations are interesting. The reason is that each portion of the memory can be referenced using an address. So it's kind of like your street address your house address that you stay in, that kind of thing. You can actually go and pinpoint, go to the following address, and there's actually a number associated, and then you can go see what is inside that address. Now, computer memory obviously can be used for many things. Let's just quickly list a few of them. Obviously, we use it for variables. All our programs, when we run and we add values, we use variables and we modify these variables, that gets stored in the memory of the computer. But our computer memory also stores the code of our program. All the C++ code that you guys have been writing, that also goes into memory. And each piece of code instruction can be referenced by an address, believe it or not. Okay, we are going to focus on this variable thing in this lecture because we're going to talk about pointers, and I'll explain to you where I'm going to with this. Now, remember when we declare a variable like char, it actually allocates a piece of memory that is big enough to store what type of data? Well, a character data type. Now, character data types, if you did some revision on some of the lecture notes that you've seen, it can typically store a value from 0 to 255 or from negative 127, I think, to positive 127 or 128. I can't remember the exact number. But effectively, it's just 256 different numbers that can be stored inside a character data type. Now, you've learned that each of these numbers actually represent a character in the ASCII table. That's what a character data type is. We look at integer data types, so int num. Integer data types can store, specifically these types of integers, they can store very, very big numbers. Okay, and obviously, when I declare a variable like this, and the computer goes and allocates memory in the computer, then it takes up a lot more space potentially than a character data type. We are not going to focus too much on how much space it takes up, rather get used to the idea that it does take up space, and we can basically look at that space and we can find the address where that space, that memory location belongs to. That's what you guys need to realize. So if you think about it, as soon as I do this, then it basically, in the memory, the street that where the memory is, it goes and builds a little house that can store a character data type. If I declare an integer data type, then next to the house of my character data type, it will create another house big enough but to store an integer. And each of these houses has their own address. That's one of the things that you need to understand. Let me quickly see if there was a question, a comment, or something, I think. No, I did not see anything. Okay, well, let's continue then. Maybe someone had a hand up. No, could not see a hand up. All right, so let's move on. Now, what is inside this memory location when you declare a variable like that? Well, the answer is we don't really know. The fact is that computer memory doesn't get written, or a bunch of zeros doesn't automatically get written in computer memory. Okay, so today we've stored a character in there into this specific location. Tomorrow we store an integer into that same specific location, and that would have then changed the value. Okay, so whatever was in that memory is effectively what was on the computer. Now, granted that your RAM, typically it loses, because it loses the electrical charge, it actually loses the stuff that's inside the memory. But when you start it up, it starts using that memory locations again for certain things, and then it reuses it for other things. So we don't really know what is in there, except if we initialize it. So as soon as I do this, then a little value appears inside that memory location. That's what you guys have to understand. So declaring creates that portion, it sets aside that portion of memory, and then initializing puts a value in there. Okay, that's one of the first things that you have to understand. And obviously, I've already mentioned that we get many different data types here. So you get integers, you get characters, the basic data types inside C++, I think, such as int, char, double, bool. These are all some of the basic data types. You'll see that a string isn't a basic data type. It's actually a much more complex container. And that's why I don't typically put it in that same list, because it basically can take up a lot of memory and so forth. Okay, let's just see. There was a question, I think. No, anything can be stored in them unless they're initialized. Well, anything can be stored in them if you declare them. It must be declared. As soon as you declare it, then the computer says, okay, we're going to ring fence that little thing so that it can be used only by that variable. And then, because some other stuff might have been in there, that's why we don't always know what is in there if it's not initially initialized. So how do we initialize a string and a character? Well, okay, well, let's just go through it. Okay, so let's say, for instance, I've got an integer here. So int num, you give it a value, all right? For a character, let's give it, give the variable a name. So let's say char, and you give it a value. You must have seen code like this. Oh my goodness, like that. That will initialize the value in there to the null value. Now the null value is basically an integer value of 0, but it doesn't have any character. It doesn't represent a specific character on the ASCII data table, and so forth and so forth. That's how you initialize it. You basically give it a value. The string data type is an interesting one because that's why I said it's a container already. So effectively with the string, as soon as you declare it, it actually does the initializing on your behalf. So that's why we handle strings, or we have to think about strings as a little bit different than the other data types. Okay, what's so special about a string which excludes it from that list? The reason is the string data type has a bunch of properties associated to it. For instance, you can look at a string and you can ask the string variable what is its length, as an example. So there's specific properties or complexities around that container which is not applicable to something like a Boolean or a double and so on. So think of it as a much more complex, not so much maybe a house, but rather a factory that has a bunch of ways to store a bunch of characters in it. Okay, so those are some of the things that you have to be very careful of. That's what you have to try and understand when you think about strings. Okay, now let's just get back to what I was trying to talk about with memory. You can just see there's another question. Sir, explain string declaration. Okay, when you declare a string, you do this. That's declaring it. And as soon as you do that, the string data type automatically initializes whatever value is in there to nothing, because the string contains nothing. Only when you start, so you can, if I do cout junk now, it won't output anything. Okay, it won't do the same as we do with integers and so on. So don't think about. That's why I say you cannot put string data types in the same category as your basic data types like integers and characters and that kind of thing. But that's not what I want to get down to. So please, I'm going to park those questions there for now, and let's continue. So now you've learned that you get different data types, like characters and integers and booleans and doubles and so forth. There's another data type that we can use in C++ that contains something different, and that's called a pointer data type. Now, we don't go and write the words pointer like that. That will not create a pointer data type. Instead, what you do is, if you want to create a pointer data type, you take one of the existing data types that we have and you add a little star to it. Now, as soon as you do that, it creates, or it changes that little box that we create into something special, so that it doesn't store a value now. Instead, it stores, and I'm going to write this down, an address. So in this little box, we now have an address that we're going to use. Okay, but what does that mean? Well, it's exactly what the word means. It basically means that it points to some place in memory. So I'm going to just, with the help of this little arrow, saying that it points to some place in our memory. Let's say there. And I'm going to point that someplace as well, and that one as well, and that one as well. Okay, that immediately changes that variable into a pointer type. But we have to read it together with the actual variable as well. So this changes it so that it says I'm pointing to, guess what? To a potential area in memory that contains a character. This one points to an integer. That one points to a Boolean. That one points to a double. So if we said that these little boxes are now pointers, then inside these boxes, we're not going to get actual values, but we are going to get addresses. And these addresses will contain a character or an integer or a Boolean or a double and so on. Okay, now let's park that for there. Let's see what questions there are. What's so special? Okay, select, okay, maybe we can see it is sort of an array. No, not yet, definitely not yet. It's just a bunch of memory at this stage. It's definitely not an array, because an array, well, it's a little bit strange because an array is also referenced by an address. So you can think of an array as a cousin to a pointer. In fact, it actually makes use of pointers to reference in the various items inside an array. So Mr. Sabanda, you're probably on the right track there. Think of a string as a type definition. Yeah, okay, that's correct, Mr. Ogden. What is the code for today? We will get to that. That's well, let's do it now, because I put myself a little. That is the code for today. Now you're going to run away as soon as you see that. Right, so the code for today, late viewing, is that code there. All right, let's move on. Okay, what if I put star star? Okay, we'll get to that star star just now. Well, maybe not today, maybe tomorrow. Pointers must hold their own inherent address in memory too, right? You're 100% right. So could we have a pointer to another pointer? Yes, you can, and we will get to that probably tomorrow. Can we have a string pointer? No, you cannot. Not that I'm aware of. That's a good question. We'll have to test that. Is which code? Okay, so they were talking about the late viewing code. Why do we use pointers? Oh, that's an interesting. I'm going to park this question. Why do we use pointers? And I'm going to try and answer that a little bit later. Okay. Did you guys not see? Okay, I did not. That's an interesting. I did not share my whole screen. Let me stop this. Let's try again. That's not what I wanted to do. Let's try this. Oh man, I'm struggling today. There we go. Okay, there's the code. Yay! Finger trouble. Can you believe it? Okay, there's the code, ladies and gentlemen. If you are watching this recording a little bit later on. Okay, for those watching it here now, don't worry about it, obviously, because your attendance is already in the system. Okay, let's move on. So we can only see your Excel screen. Yeah, I saw that. So doing the standard Discord streaming blunder of stream. Yeah, I know, exactly. Typical blunder. There we go. That's what I wanted. Okay, so let's just recap what we said. And let's see exactly what happens at this point in time. So if I declare a character, so let's go and declare a little character pointer here. Let's give it a name. So let's say pointer char. As soon as I do that, a little box gets created. And what is the name of that box? If you want to think of it, it has a little label on that box called PTR char. Can you see I called it PTR because that is a pointer type now. If I do that, let's give it a name, PTR int. That is a pointer type to an integer. This one, and that's just a name, ladies and gentlemen. I can call obviously that thing whatever I like. Just think of it, that box there has a specific name to it. This one obviously will have something like pointer. Since we're in the same trend, let's just do that. And then this is maybe double or something like that. Okay, so each of these boxes now has a name. But what is in these boxes? We don't know, meaning their pointers do not point to anything itself. Now, there are two different ways in which we can get these boxes to point to something. One of the ways is the following. Let's assume I create another variable here, just a normal character variable, and I'm going to say ch. Let's say name, or let's make it input. Right? As soon as I do that, then another box and I'm going to create that box in that location right there. And that box also has a name called ch input. Now what I can do is, can you see that this box says it is a pointer that's going to point to a character data type? I can actually now say, hey, you PTR character, you are going to get and point to the address of CH input. And that's what the little ampersand means. Remember when we passed by reference, it just says the address of. So now I could say the address of CH input. What is the address of CH input? Well, now let's assume we're using the addressing scheme that's here in Excel. That is F11. So effectively inside this little box, there is now a value called F11. And if I want to visually indicate this, let's go and draw a little arrow that points into that location right there. Okay, now what is inside this little box? Well, nothing yet. Can we put something in there? Yes, we. If I do this, CH input, let's just make this a little bit smaller. So if I say CH input is A, as soon as I do that, a value A appears inside that little box. And then I can also get access to that value A by using this variable. Now, when we evaluate the value that's inside PTR char, for instance, if I do cout PTR char, what will it output? Well, in this case, it will output the value that's directly inside that little box, which is F11 in this example. But if I say, hold on, output the dereferenced value, meaning the thing that this thing points to, the value of that pointer. That's what you should read it as. The value of pointer character, then it will output A. Okay, so that's how we get to the value that's inside a specific pointer. Okay, there's a bunch of questions. Let's go down. Let's read the questions. I struggle to understand the importance of pointers. As I said, I will cover this later on. So doing the standard, yeah, you'll need them. Yeah, at Classmates, I've never attended late class. Okay, if you attend a late class, you don't need the code. If you attend here, you don't need the code. It's only if you watch the video at a later stage, then you must complete the late register. That's the link is at the bottom of the YouTube video normally. So we would need pointer data type, variable name. So we would need, okay, I'm not sure what the question is. They should be okay. So, sir, can we use that pointer to pass a variable by reference to a function? Oh, Mr. or Mrs. Tamala, that is a very, very good question. Because remember that location, currently I'm pointing it to a variable. But if you remembered, I said that in memory, we can also have code. So can you have a pointer that points to code? And yes, you can. That means you can effectively pass code into another function inside your program if you want to, by using what they call function pointers. We're not going to go into function pointers. It's not a technique that we want students to focus on, because it's definitely something that we use in the C language a lot. C++ language gives us better ways of using function pointers. So this means CH input is now found in F11. Well, let's just quickly go through this thing again. So F11, the value F11 is inside D7, and F11 contains the actual value. So that's what I want to do. So the actual value that's stored inside the box that belongs to this variable is the value F11. It contains an address. And the address that it's currently pointing to is F11, which is the value A. Let's go some more. Is there an address A here, an address of F11? A is the value that's inside F11. Injection. Not sure what injection is, so we would name So we would name is pointer data type variable, now, as in if we can two int variables, int num and int2. So how would you name the two as pointer variables? I think we covered that. If you want to make a pointer data type, what is the magic little character? What is the little thing? You put a little star. So if you want to change a variable into a pointer data type, you have to put a little star into it. Then you change the variable, and you change that variable to a pointer data type. That's how you make it a pointer data type. Not PTR or whatever. Definitely not. I think it is the other way around. Okay, so assuming I had an int array, okay, I'm not going to go. Okay, I'm int pointer x. X is foo, depends on what foo is. The address of x is 1, then foo is also 1. That's effectively what the x plus plus, not x plus plus, but the value, the div referenced x plus plus. That's what you're going to have to do. X plus plus will increment the address of x. Yeah. So x plus plus is not correct. It's star x plus plus. Okay, thanks. I mean, if we have multiple variables, then it is the name. Oh, multiple variables. Well, technically speaking, multiple variables, you actually just use it. So my naming convention here isn't great. This is probably pointer, let's say input or something like that. That's more realistic. The only reason why I named it here char is so that you guys can realize it is a pointer to a character. That's the only reason. Okay. All right, let's park this and let's see if we can answer the question of how do we also get some values into these pointers. Okay, let's delete all of this again, and let's get rid of that, and get rid of that, and get rid of that. Okay, so now we've seen that if we create let's create a more realistic one. Let's say an integer, and I say int num, boom, as soon as I do that, it creates my little box. Né? And if I want to change this into a pointer data type, I just do that, and then it creates a little box, but now it realizes that this little box cannot store a value, it cannot store an integer, it must store an address. Now there's another way in which we can get this pointer to point to an area in memory that belongs to an integer, and that we do with the new keyword. So we can say, hey, int num, you are now going to point to a new integer. And as soon as that happens, it creates what we call an unnamed variable. So basically in memory, it creates a little box, but there's no label on that box. The only way that we can get to this little box here is through our pointer. So as soon as I did that, the value that goes into this little box becomes, what is it? F8, meaning it has a little pointer now that points in that location. So we did this through the new keyword. So can you see we said, hey, int num, meaning, hey, this little box here, let's say that yellow box, Mr. Yellow Box, you are now going to point to a new integer. And as soon as I do new, it actually allocates memory on a special memory in our programs called the heap for enough space for an integer. And that's how we create what they call an unnamed variable. And now, if I want to put a value in there, the only way that I can put a value in there is by dereferencing my pointer type. So I can say star int num is equal to 8. And so as soon as I do that, it says, okay, this pointer that it's pointing to, let's go into that box and give it a value. That's how you basically put a value in there. Another thing which can happen is I can also immediately after this run the command again. What's going to happen now? So I've created a little box. Remember this little box right there? Let's give it a green color. I've created a little green color, and immediately after this, I just change it again. So now it creates another box, and I'm going to just put the box there, and let's make it orange. And I changed my pointer now to point to that location. In fact, the address there is now F9. What happened to this little box? Well, it stayed there. In fact, the memory that we allocated to that box doesn't automatically get freed up again. We can go and rinse and repeat this command, and eventually, how many boxes? Well, so many boxes will be created, all borders, and eventually that guy is going to point to that little box. But can you see, I've basically wasted all of this memory. So that's why, together with the new keyword, we also have to realize that there's another keyword called delete. That means if I do this, delete int num, then it will delete the box that int num was pointing to. So if I just did this code here, I'm sorry, just get rid of all of these things, then effectively it deletes that little box, it gives it back to the operating system, making it yellow, and this thing then still points to, well, believe it or not, it actually still points to that location, but you can't use it. As soon as you want to use it at this point in time, or after you've deleted it, so this thing still points there, believe it or not. But if I now do this after this code, and I say star int num, here's my star, is equal to 8, as soon as I do that, my computer will crash. And it says, hold on, you're trying to access memory that was not allocated to you. So this will cause a crash of your program because this box doesn't belong to this program anymore. The operating system basically took it back. Because why? We deleted it. Okay, so now you've seen two ways in which we can basically point our pointers into locations. Now this new and delete, this becomes very important. This is what we also call deleting stuff, is what we call memory management. Now higher level languages like .NET framework languages like C# and Python, they actually do these things behind the scenes. So they create new variables or spaces for these variables on the heap, and then it automatically goes through processes called garbage collection to actually go and delete this memory again once it falls out of scope. Lower level languages like C++, for instance, we have to manually go and manage this memory on behalf of the program. So let's just see, there's a bunch of questions. I mean, if we have multiple variables, then what is the naming convention? Yeah, this looks good. So Mr. Sibanda, that looks like a very good naming convention. What is the difference between a pointer and a variable? A pointer is a variable, but instead of it storing values such as characters or integers and so on, what does it store? It stores an address. So new is a reserved word. Yes, it is a reserved word. Well spotted there. So when working with the pointer variables, we don't need to include the star at all times. Well, whenever you want to get access to the values, you have to use the little star. So that's what they call dereferencing it. So if we try to put a string in a pointer that points to an integer, we will get a mismatch. In fact, yeah, if you try to do this, that's an interesting question. Let's demonstrate this. So let's say, for instance, I created, let's get rid of that box again. Boom. Okay, let's get rid of this value as well. Currently, this pointer points nowhere. Okay, I mean, I've just created this little box. If I now do this, if I say int num equal to new character, then guess what's going to happen? Your compiler will not compile this program. It will complain in saying, listen, it cannot understand what you're trying to do here because you're trying to create a new variable of type character, which is associated to a type integer, or that was supposed to be an integer. So your compiler will not allow this type of thing to happen. So the question that that was asked about if you point to a string pointer or a pointer to a string or whatever, then pointing it to an integer, Mr. Milne, that is, the compiler will not allow that to happen. It's orphaned memory, yeah, that's kind of what it means. A string can take in an integer, but not the other way around. Actually, a string takes in characters, a number of characters. Think of it rather as an array of characters. In what library is delete? It's not a library, it's part of the C++ language. So how do we access the values within the previously defined boxes? Well, you can't, that's the problem. So Mr. Suhui, and that's why Mr. Milne actually said that it is an orphan memory, because these things they don't have parents anymore. You can't access them anymore, which is horrible. So how does each element in an array take memory, or is it the array itself reserved the memory? Fixed dimensional arrays gets allocated memory during the declaration, but you'll see with dynamic arrays, we allocate memory as soon as we do that little new keyword, and that's what we're moving towards. We left with less than 10 minutes, but I still haven't got my answer. So what is the importance of a pointer and its role on code? Geez, like Mr. Pitsuane, you are very demanding. Okay, we'll get there. Don't stress. You will see within maybe in the next 10 minutes, but maybe even tomorrow as well, that we use pointers to allocate memory for dynamic arrays. Okay. What is the problem with the arrays that we have seen so far? Meaning we've created variables, we've created arrays already. Remember we did this. We said let's say array of ints, let's say array of numbers rather, and we did something like this. The problem with this type of an array is that the programmer must know beforehand the size of the array. There is no way for the user of the program to decide how big the array should be. Let's consider a problem where we have to have a program that reads in the semester test marks of the first semester test. If I write a program for the class of 2021 using a fixed size array, potentially I will not be able to use that program for the class of 2022. And that's where dynamic arrays becomes important. And dynamic arrays means the user, when they use the program, might get an option. How many students do you want in your class? And we will say, in this example, I think this year we've got 500 students registered for Computer Science 1A. We will type in 500, and it will, at that point in time, we can allocate memory for 500 students. Maybe next year there's only 400 students, and then the user will say only 400. And that's what dynamic arrays is, and that's where we use the pointers. But pointers get also heavily used in object-oriented programming, where you can call what they call objects, and you can move objects around from one function to another and send objects into what they call methods. All of that through these things called pointers. Okay, so that's where we use them, and we use them quite often. In the first semester, the place where we're going to use pointers is in the creation of dynamic arrays, right? So what time does the prac lecture start on Fridays? Prac lectures session starts, I think it's 5 minutes to 2, and it goes on until I think 6:30. Just look at the learning guide, that's when the prac lectures is. This Friday, I will not be able to actually run the prac lecture. I've already pre-recorded it, but I will put it on YouTube on Friday morning sometime. Okay. Cool. Prof. Coulter will be in the Discord channel, and all the assistants will also be on the Discord channel on Friday during the prac lecture. If you do have questions regarding the prac and marks, etc., etc. What if we ask for input from the user, as in how many students, and then later have it? That will not work. So, Mr. Sabana, you can actually go and try that, and you will see that your compiler is going to complain that I is not a constant. So what's the attendance code? The attendance code is for those students that watches this recording afterwards. Okay, after it's been recorded. Okay, I think what I'm going to do now is just going to quickly show you the lecture notes and just quickly run through this. You'll see that the lecture notes goes through talking about how do we talk about pointers. We'll move into dynamic arrays. So tomorrow, I just want to spend time on dynamic arrays, specifically focusing on why do we use these pointers, okay? The first use case instance that we're going to use pointers for here in Computer Science 1 is in this creation of dynamic arrays. So that's what I'm going to focus on tomorrow. But for now, you can read through the lecture notes specifically regarding pointers. Most of the important salient points have been covered in this lecture now already. There's a few things that I think is worth your while if you go read through this, see how it fits in with what we've covered already. So the definition of a pointer, remember that memory has locations, meaning addresses. We've used memory before, specifically by the call by reference, and when we actually used arrays. Pointers is a type, just like you have an integer and a double, etc., etc. A pointer is another type that we have. Double, this is how we declare a pointer. Okay, here's a bunch of how do we declare a bunch of pointers. Here's an example of declaring two pointers, P1 and P2, and declaring normal variables, V1 and V2. Okay. Notice the differences. The pointer types have little stars in front of them. So I don't think we have a lecture. There is a lecture tomorrow. Remember, tomorrow is a Monday schedule. I've already covered this, and I've already mentioned this. We've already sent emails on this. There's notices on Eve. So yes, there is a lecture tomorrow because it is a Monday schedule. Next week, we'll be finishing our theory. Definitely, we will be finishing our theory next week, and then it's just revision, 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 etc., etc. Okay, thank you for all the students that also assisted with tomorrow's schedule. Right, where was I? Okay, here we go. So what is the differences between addresses and numbers? An address is a number, but a number isn't always an address. Okay, so that's important. Well, it's depending on how we use it, so don't get confused too much with this. Okay, I'm not going to go through all of this. We've already talked about this. This is where they talk about the dereferencing operator. So remember I said, how do we add a value into a pointer? Well, you put a little star in front of the variable name. So star whatever, and then we can actually get the value from that pointer. Just note that there's a little, obviously a syntax error there. See out the little pipe operators are not there. Star P1 means we dereferencing the value that's in P1, meaning get the value that it's pointing to and then output that. That's what it means. Okay. The ampersand operator, this is the address of operator. We use that if we want to assign a value to a pointer if we want to. Here's a few examples of pointers and the values of them. In this case, we've created two variable pointers, P1 and P2, right? Added some values in there, and then as soon as you run P1 is equal, oh sorry, P2 is equal to P1, then basically both of them points to the same location. All right, but if you do star P1 is equal to star P2, then you're saying the value that was in P2 is now the value that's in P1. All right, that's called dereferencing again. That's just, so remember, whenever you see the word star in front of a variable name, rather say the words, the value of P1. That's how you should try and put it in your head. And we talked about the new operator, and we talked about the delete operator. Okay. We'll talk about this a little bit later on. Yeah, and talking about a little bit memory management and so forth. Okay, so ladies and gentlemen, what we're going to do tomorrow is, please read through the lecture notes. I think it's worth your while to talk a little bit, to work through these lecture notes. We haven't talked about dangling pointers yet. I will cover that tomorrow when I talk about the arrays and dynamic arrays. So this is that principle of dangling pointers, and I will demonstrate what happens in those cases. And tomorrow we'll go and talk about dynamic variables and creating variables on the fly, and then while dynamic arrays, letting this array grow or getting the memory back by the new and the delete keyword. And that is it for today. Ladies and gentlemen, have an excellent day. Do we always have to use a PTR after a? No, you don't have to. So Mr. Manji, I think, you don't always have to use PTR as in your variable names. Are there assistants physically on campus? No, there isn't assistants physically available on campus. So are we going to get an example of how to do a 2D array for P05? We have covered 2D arrays already, and there was examples of that. Did you not look at last week's tutorials? And I think there was a whole lecture that Prof. Coulter actually did on 2D arrays. It was pre-recorded. It's on Eve. 2D arrays, libraries, and namespaces. Have a look on Eve. Yeah. So thank you. See you tomorrow, guys. Have a good evening. Bye-bye.